All right. Hey everyone. Looks like we are live. So quickly confirm if you can see my screen and hear me properly. I want you to quickly confirm this and we can then get started. Okay. Looks like you can hear me. Cool. So let's get started. We'll be, where is my screen? Give me a sec, guys. Yeah, this is the one. Okay. So we'll be doing more of Google coding interview questions. In the last stream, we did the first two questions, order of people heights, and let me zoom in on the screen. So we did first two questions, and now we'll be moving on with the next few questions. And if you are interested in getting access to the list, I'm sharing the URL in our Discord. And if you're not aware where our Discord is, it's at bit.ly Discord Rachit. So I'm going to paste the problem links or the list of the problems on Discord. That's what I'm doing. All right. So I have pasted it. I hope it's visible. All right. So let's start with the longest repeating subsequence, which looks like a classic problem. I think it's very intuitive that we are going to use dynamic programming. Let's see. So you're given a string and your task is to find the length of the longest repeating subsequence such that two subsequences don't have the same character at same position. All right. Damn it, I am not that good with my new setup, so mind me for that. Okay, any problem in the chat so far? Let me check the chat once. Okay, everything is looking fine. So we are given a string and its size, and we have to find the length of the longest repeating subsequence such that two subsequences don't have the same character at the same position. Okay. So if this is the input example, they are saying that ABC is the subsequence. It's not substring, first of all, it's subsequence. And it's happening at various indices and it's repeating, and this is the longest. Okay. So the output is 3, which is the longest length. Okay. All right. So we'll be solving this problem. And before we do, let's hear the message from our sponsors. So today's live stream will be sponsored by 𝗣𝗥𝗘𝗣.io. It's a really wonderful website and I love it. Being a software developer, they have courses on almost all kinds of languages and even system design. And even if you're doing coding interview preparation, they have a bunch of good courses. They also have guided paths. So it's a really good website, and they even have browsers in the window, Chrome window. So you don't have to navigate here and there. You can do a very seamless experience just in the browser. And the good thing is Educative Unlimited, it's you like pay once and you get courses to all, and you get access to all courses, which is like 360 plus. So you get access to so many courses just by paying once, and it's a membership kind of thing. You have annual and monthly plans, so you can go to the link which is in the description, also going to flash on the right side of screen. So you can go to this link educative.io/Rachit to enjoy a discount. They already have a good discount on for Indian users, but yeah, you can get extra discount if you need. All right, moving back to the problem that we are going to solve. So we have, okay, longest repeating subsequence. So I think if we have something like, let's say A, B, D, and let's say A, B, D, and then let's insert a bunch of random values like maybe something over here, something here, something here, and something here. Wait, let's not in something here. Okay, so if we have something like this, we need to understand that the output is ABD and ABD because it's a subsequence and it's the longest one. So this A, then this B, and this D. So this is one subsequence, and the other one is this A, this B, and this D. Or you could have taken this A as well. Okay. So if we want to use dynamic programming over here, we can do something like I'm using a recursive function. So I'm thinking of something like dp0, it's going to tell me that, okay, I am at 0th index and I'm going to find the longest repeating subsequence from, so I'm taking 2 pointers, I and j, for example, and I'm pointing both of them to the start and I'm saying that, okay, that might be problematic. So let's understand what we can actually do. Yeah, I think this is making sense. So I and j can point to different, yeah. So I'm thinking that I can be here and then j can be here. And now we have a choice that since these are equal, what I'm planning to do is I'm saying that, okay, so this is one character that I'm picking. Now what I need to do is I need to search for the longest repeating subsequence in this substring or in this suffix of the string. But now my I and j will move forward. So now I will move this way and j will also move one forward. So whatever answer for that happens, so basically I plus 1, j plus 1, if si is sj. So if my ith and jth characters were same, which was the case in this way, so I'm picking these in the answer and I'm saying that the remaining longest subsequence which will be repeating would be given by dp of I plus 1 and j plus 1. So what do I mean by that? I plus 1, j plus 1 becomes this. And now we are going to look for the longest repeating subsequence in this particular string, in this particular suffix. And I and j pointers have been updated. In this case, we are going to get BD because this B and this D followed by this B and this D is the longest repeating subsequence. So the value for this will actually be 2 and we will get 3 as the overall answer. So this is one of the intuition and I am going through this. Why? Because I have solved a lot of problems based on longest common subsequence or longest common substring and all those things. I hope that is making sense. Let me go through the chat section once. So someone is saying spoiler alert LCS. Yeah, it's similar to LCS, but I'm kind of, one thing that we have not ensured is what if the ith and jth characters are same, and that's why this dp state is not actually making sense. Because when you move from, so basically let me zoom in on the screen a bit further. Hopefully that will help. So I think this is better now. So what I'm saying is, when I was over here, I saw that I and j was same. The characters at ith and jth position was same. So I'm taking them and I'm going forward and I'm saying that now my dp state is this. But I don't think it's correct. Why? Because now this state is not enough for me to get the correct answer. Why? Because I plus 1, j plus 1 is only telling me the pointer's position. I'm still missing a very important state information in this representation. I am missing that this A is now picked up and I cannot use it again. And this is going to break this. So basically this is an exclusion list of indices, and this will become this will include the ith index. So exclusion list is a list of all indices that have been utilized and now you cannot use it further. And once you have such a DP state, it's going to be not polynomial, but because this is exponential, like this list and DP states can vary quite a lot. But I hope my point is making sense. What I'm trying to communicate is, even if I and jth characters, which was this A and this A, these were same, and I'm going to the i+1 and j+1 positions, but this state is incorrect. It's corrupted. Why? Because it's not having any information or memory about that this A was already captured. Now I can't use it again. And this makes the problem really hard. So I'm not sure why, I'm not sure even if the solution for this exists, because this DP, this third thing that we have introduced, it's a set, it's a vector, it will keep on grow. And based on different strengths, it will have a lot of different permutations and combinations which are possible for this exclusion list. So the number of states in the DP now have exploded quite a lot. I hope my point is making sense. Let me go through the chat once. Damn it. We have spam, just ignore that. Alright guys, first of all, if you are watching the stream, make sure you also hit the like button. It will just take 3 seconds, but make sure that you do that. Do you have a sense of what I'm trying to say? And let me just remove the spam from the chat. Anyone is having any questions, just ask me in the chat section once. All right. So I'm not sure how to solve this problem because it's kind of a tough problem for me. So I'm going to get to the solution once. So they are also saying that the basic idea is the same as longest common subsequence. And how are they handling this ISJ behavior? So this is exponential. This is not good. Let's see the approach 3. Okay, so the time and space complexity is order n square. And they're using DP, but I'm not sure if DP state is correct over here. Let me actually check this. So I'm going to copy the solution. I'm going to paste it here. And I'm going to try my own test case. So can I do that? Custom test case, yeah, exactly. What I want to, in my test case, what should be my test case? I'm not sure. Let's see if this works. So I'm trying something like A, Z, A, something like this. So what will happen over here is, let me add E, B, C over here. Yeah. So now what will happen is, if you will notice this test case, so in this test case, my point is, if you are only taking the pointers in the DP state, what will happen is, when you do this A and this A, right? Yeah. Correct. Yeah. So what I'm trying to say is, when you take this A followed, and let's add something like Y over here. So the answer for this is obviously, I think, 1, because only A is repeating. Other than that, nothing is repeating. The answer for the longest repeating subsequence over here is just 1, because A is repeating 3 times, but it's not repeating 4 times. So you cannot take AA, because you want you want another a somewhere over here for a to be the answer, which is not the case. But this case might fail the approach. Why? Because if you take this and this a, and you just take your pointers from z, y, a, b, c, a and b, c, a, then they can still return 2. So you are using this a twice, and because you are not capturing this in your DP state of the 2 pointers I and j are no longer telling you, okay, something had been already picked up and you have to ignore that. So this is the problem, and I think this will fail over here. So if I try to run code, do I also need to input, I think I also need to give the size of the string. Yeah. I think it's 6. Run code. There is no output. I'm not sure why. Let me use id one once. So let's zoom in on the screen. Let's use, and I'm going to call this over here. Let's call it s.size, and string s equals something. And our string s is nothing but this thing over here. See, the output is 2 over here, while it should be 1. Yeah, so I think it's a really tough problem to solve. Global array for exclusion list does not make sense because it's a DP state, and exclusion list is going to change based on the different choices that you're taking, different indexes. So basically for given I and j pointers, you can have different exclusion list based on the choices that you had made previously to reach at this point. So global array does not make sense over here. You need to maintain. So basically think of it, I think of dynamic programming in the sense that it should have enough information so that it's a sub problem, right? Sub problem means it should be clearly defined. Right now it's not being clearly defined. Just having 2 pointers I and j is not enough to define the sub problem, because you also need a third degree, which is, or the third state, which is, okay, what are the indices that I've already picked so that I can correctly find out what I need to find out right now. So that is the problem over there. Yeah, but the number of exclusion, so exclusion is not just a Boolean which is having 2 states. So the number of states are exploding. It's no longer polynomial. That's the problem. I'm not sure. This is a tough problem. I don't think longest repeating subsequence. Okay, so a lot of websites have solution for this, I think. Let me try something like Stack Overflow. Okay, nothing on Stack Overflow. Okay, we do have longest repeating. Yeah, I don't think again, this is also the same thing. It's not having enough. Yeah, so they are doing the same. Everyone is doing the same thing. Like this will also not work, I'm sure. It's using LC. Yeah, it won't work, man. Um, No, it's having multiple strings. That's not what I need. I don't know. I'll have to search, but I'm pretty much sure that this is a very tough problem. So I'll actually ask Coding Ninja's team to look into this because I think this is a really tough problem. Um, do you have any updates in the chat section? Anyone is having any ideas? All right. I think let's move to the next problem. This problem I'm going to check again later. I'm definitely sure, if not definitely 90% sure that this is a really hard problem, man. I'm not sure how to solve it because I think I'll need to, like, it would be exponential solution even if I code it. So yeah, I'm ignoring this. Let's do the next problem, clone graph. I think I know what this problem is. I think I also did this while I was in Microsoft and I was probably making a YouTube video on this. I'm not definitely sure, but I think I did it for linked list, not for graph. So this should be interesting. Okay, so we are given a reference. Let's see the problem. Yeah. So we have to write the function clone graph, and let me move it a bit further. We have to write a function clone graph. It returns a new pointer, and the input pointer, and the input is again a pointer to a graph node, and we have to clone it and return. So basically, we have to make a deep copy. So if you have some graph structure, and I'll quickly use a pen to demonstrate this. So let's say you have some graph like this. And is it a directed or undirected graph? Let me check that. Clone graph, yeah. Connected undirected graph, okay. So we have some graph like this, right? And now the idea is we are given one pointer. So let's say we are given this thing. So we are given pointer to one graph node. And the idea is to return a new pointer. And it should be, we have to perform a deep copy. So if you are a software developer, you probably know what is a deep copy. But in other case, I will explain what it means. So basically, if this is having 1, 2, 3, 4, 5, 5 nodes, so you have to create the 5 nodes, and is it having some data? Okay, so it's having int data. Okay, so let's say it's having information like some numbers, right? So 3, 2, 0, 1, and 9. So what deep copy means is you have to create all the 5 nodes. So this is 3, this is 0, this is 1, this is 2, this is 9. So you have to create the new nodes. The address of this and this will be different. So the address of each nodes will be different, but the structure of the graph should be exactly same. And it can have duplicates also. So if this is 10 and this is also 10, so this should be 10, this should be 10, right? So something like this, you have to perform a deep copy. So this is exact replica. It's just the address of all the nodes is different. So this is what the question is. Is the problem clear? I'm going to give you few seconds before moving to the solution for this. I think it's a good problem. Let's do this one. All right. Okay. So I need to clone the graph. So this is the class graph node. It's having int data. It's having constructor. It's having neighbors and different constructors for okay. 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 So using, I'm doing a queue. What I'm going to do is I'm basically trying to do a BFS. I can do DFS, BFS doesn't matter, but I am doing BFS right now. What I'm trying to do is I'll do BFS. I'll start with the this node, which is cur. So the current node, I'm going to start a BFS with it. And for every new node that I'm encountering, I'm going to create its replica, and I'm going to use the neighbors to create those mappings with the newly created nodes. Okay. So if I talk about my example over here, when I'm at 3, I'm going to create this node 3, and then I'm going to check the neighbors of 3, which are 2 and 10. So 2 and 10 do not exist. So I'm going to create new nodes for them. All right. And then I'm going to assign 2 and 10 as neighbors of 3 for this newly created node. For this newly created node, there were no neighbors right now. So I'm going to do that. And then I'm going to push 2 and 10 to the queue. Then I'm going to push this 2 and this 10 to the queue, right? And then I'm going to pop 2, look at the neighbors 3 and 9. 3 is already created. So this is the replica for 3. For 9, I will create this replica over here. And then for the neighbors of 2, I'm going to set for this 3 and this 9. So basically, I am doing traversal on the older graph, simultaneously creating new nodes when needed. So I'm also going to need a lookup map, which gives me from the given pointer. So I'm going to need a map for this pointer to this pointer. So I need a map that points the address of 3 in this version of the graph to 3 of the new version or the new replica that we are creating. So that's one thing that I need. And I think that should be good enough. Because when I am at 9, for example, I will look in that map that, okay, give me the replica of 9. It doesn't exist. So I create a new node. I get the replica. Now I need to set the neighbors in this new replica, which is this one. I need to set the new neighbors correctly. So for that, I need the replicas of 2 and 10, which again, okay, I think it should work. So let's do it. I hope this is clear. What 𝗜𝗓𝗧𝗘𝗥𝗩𝗜 is suggesting over here is one. So basically that's something which I had done in my video also. It was in linked list, but it won't work over here because this is a graph. So, or I'm not sure, I'll have to check, but I think I have a pretty straightforward solution in my mind. So I'm going to do that. So what I'm going to do, q.push the current node. Now while not q.empty, and the good thing is the graph is connected. So I start DFS or BFS with one node, and I'm pretty much sure that all the nodes will be covered. So that's also a good thing. Auto, let's call it the head node, for example. That's better. And now the current node, let's pop it, right? And now I'm going to use a utility function known as getReplica. So getReplica of current node. Let's call it auto current replica. So I got the replica, that's good. And now what I want is I want to set the neighbors correctly. So let's do that. Also we need something like 𝗜𝗚𝗧𝗘. So 𝗜𝗚𝗧𝗘 of head is true. Let's do that. For auto child and neighbors, so neighbors of current. So I think it should be something like this. What is the key? Neighbors. So let's copy that. And if you'll notice right now, I have not implemented this function, and that's how you should also generally try to do things in interviews, because this saves a lot of time and it's very verbose when you're doing like this. You're essentially communicating your direct ideas with the interviewer. If you start implementing this, it's going to be technical detail. It's not reflecting on how well you are architecting the code or how you are thinking or how your mind is. So the verbosity decreases, and that's why I really prefer this. I'll implement this later. It's just a technical detail. Similarly, I will declare this map later. So yeah, that's my point. Okay, auto child replica is get replica of child, and then I can say that the current replica dot neighbors actually yeah, let's see. What is the spelling? Neighbors dot push underscore back the child replica. You see what I'm doing? This is like really good thing that I'm doing over here, because I'm not only just creating the same graph, but even so this neighbors is an array, like it's a vector. So if you are having, let's say 3 is having child 2 and child 10, it's having pointers for 2 and 10. I'm even duplicating that thing, that even in the new replica, which is on the right side, if let's say the pointer for 2 is coming before the pointer of 10 in the children or in the neighbors of 3, then I'm also ensuring that in my replica. It's not that initially 2 and 10, 2 was before 10, and in my case 10 is before 2. That's not the case. I'm even maintaining the same order. So that's pretty good. And that should be good, I think. Um, I have to return the replica. So at the end, I can say return get replica of the head node. So I am not pushing to queue. Let's also do that. So if not visited child, what is the pointer of child? I think child itself is a pointer. Yeah. Yeah, it's a pointer. So if not visited child, I am going to mark it as visited, that I have visited you, and I'm going to push you to the queue. So I'm iterating on the older graph, not the replica. But while I'm iterating or while I'm performing BFS on my older graph, I'm creating replicas when needed. And so this get replica function is responsible for doing that part. So let's now jump to that. Okay. Void get not void, node star get replica, node star input node. So let's call it in. And if some maps, if lookup dot find in equals lookup dot end, this means that I have to create a new node in the replica graph. So I can say that lookup of input is nothing but I think new node, and what can I pass in the graph node? Okay, so I can pass in something like the inputs data or val, what we are using, data, yeah. So if I do this, I think we are creating an empty thing, and then we can simply do a return on lookup of in. What is this lookup? It's a map from node star to node star lookup. And before calling this, let's clear it. So let's go through this step by step. I'm doing BFS, so I'm pushing the current head. I'm saying that I have visited you. I have not declared that. Let's do that. Map node star comma bool comma visited. Let's also vis.clear init stuff basically. Okay, so init stuff is done. The main algo starts. We are starting with the BFS. Head is there. I'm saying push. I'm saying pop it out. And then I'm saying get me the current replica. If it doesn't exist, we create the replica and return the new pointer. Perfect. I get the replica. Now I'm iterating on the children of my current neighbors. I'm saying that, okay, get me the replica for each neighbor. That's good. And I'm saying that, hey man, the current replica, which is the new node that we have just created, that let's push it to the neighbors of that. And if the child is not visited, let's go through that. I think it should work. Yeah, I think this should work, man. It's very neat solution, I believe. Let's try to run this and face the compilation errors. Here it is. It's saying void_char has incomplete type. Line 51. Okay. q.front. It's been a while I had been using C++. q.pop. Okay. So now what is the issue? Okay, current replica is a pointer, so we cannot use the dot notation. That is a fair point. All right, guys, what are you guys doing? Oh, it's working. You want the question link? I'll paste this, no problem. The Discord, first problem. Let me paste this as well. So I've pasted the first problem in Discord, and the Discord link is this. Okay. Do you want me to paste this in the chat? Let me actually paste it, and I'll actually pin it also. Can I zoom this screen a little bit? Yeah, I can. That's better. All right. Whenever I see graphs, I puke. And the user's name is I have no idea about what I'm doing with this life. Graph problems are not that scary. I think this is graph and linked list, so it's like a really scary problem, but I think we did solve it, and I hope it's easy for you to understand what we just did. Is my approach clear? I will also go through the code again. Let me maximize this. So I did the basic initialization stuff. The main algorithm that I'm using is basically I'm using BFS, and I'm iterating on the older nodes, older graph, which is the input graph. And while I am doing that, I'm creating the replica nodes ad hoc on the fly. So as I'm doing BFS, I see that, hey man, I need a replica, and this function is doing the beautiful stuff. If we have a replica for this node, and the beauty is we are not playing around with the values. We do not care whether this is holding integers, it's holding string, or it's holding some other objects. It can do whatever it wants. We are not relying on that. We are playing on pointers. So we get the pointer to the input node in the older graph, and I want a replica for that. So I'm having a lookup map, and I'm saying that if it doesn't exist, create a new replica graph, replica node, only by the data for that. I'm just passing the data. I don't need the children and the neighbors. That I'm going to do in the BFS over here. So if you will notice, we are popping the older graph nodes. We are pushing the older graph nodes. It's just that we are creating replicas. We are creating the current replica, the child replica, and not every step we are creating. If it's already created, we simply reuse so for every node in the input graph, we are only creating one replica. And I think it's pretty good and neat. The solution is pretty straightforward. I think you're not using Wisted anywhere. I am using it over here. Otherwise, you will be stuck in a cycle. That wouldn't make sense. Are you married? Yeah, that is definitely a valid question for a coding live stream based on data structures and algorithms. But the answer is yes. All right, guys. Have you liked the live stream? If not, a lot of people are watching this, and I really encourage you doing that. So if you are still online, hanging around, solving problems with me, just make sure you also click on the like button. All right, I think this is pretty neat. Let's actually submit this. I don't think we have submitted yet. I hope this works. So compilation check is fine. Large test cases is also fine. And we did get time limit exceeded. Damn it. The score is 90. Time limit exceeded. Okay, so I think if we use unordered map, this should get better. Because unordered maps are using hashing. And if you're not sure what this map, unordered map is, believe me, you just need to go to YouTube, search for, let the YouTube open. Just search over here for Rachit C++ STL series. I have just 2 videos. Okay. And if you'll just go through that, everything will be clear. Trust me. So it's having close to like 500,000 views. And it's really good series. And I definitely recommend you. Just watch the first video. That should also be good. Okay. Time limit exceeded. Yeah, unordered map. Let's click on submit and see if things get better. I hope they do. And it did. All right. Let's move to the next problem. I think we have done, let's refresh the page once. So we have done this. I think now it's time for submatrices with sum 0. Let's do that. I think all these problems, okay, so I have been doing a lot of problem solving, not very regularly, but it's been close to 6-7 years for me that I had been, like the initial 4 years, I had been really doing problem solving almost every day. But for the last 3 to 4 years, you can say that I'm not in regular touch, but I can still say with my experience that this list that we are solving, it's having really good problems. Not that easy, really good problems. So yeah, I definitely recommend that if you want to up your game, solve these problems. These are really good. Submatrices with sum 0. Okay, submatrices with sum 0. I think it's pretty much clear what we have to do. So we are given a matrix, I think. Okay, and I don't think we need it, but that's good if it's given. Example. Okay, so 1 minus 1 0 0. The output is 5. Yeah. Okay. There are only 5 submatrices whose sum is 0. So, okay, these are the 5. 1 minus 1, 0. Okay. So, just to explain the problem, let me go to the next page. Take the tab. So, 1 minus 1, 0 and 0. There are 5 matrices with sum 0. So, I'll highlight that with yellow color. So, this is 1, 2, 3, 4, and I think 5. So these are the 5 submatrices which are having 0 sum, and given a matrix for this input, the answer is 5, and that's what we have to do. Interesting problem. Okay. Anyone is having any ideas or some suggestions or any doubts? Are you in India? Yes, I am in India. For the system, which book should I refer? I think DDIA is a very good book. In fact, I also have an ongoing series based on that book. If we'll system design, Rachit. So I have a bunch of videos going on system design, so you can check out that. Or if you want the book, so basically I'm also shaping the content towards system design, because it's been quite a long time for me also to work as a software developer, and I'm growing in my area. Like right now I'm in SG3, so I have enough experience now to talk about these topics, and I'm also referencing this DDIA book, which is really good, and I don't just read it, but I try to also question that with my experience and try to share the summary with you guys. So this series, I'm really excited about it. And if you want, you can go through this series, or you can go through the book. If you'll go to the description, you can see the book reference over there. All right, any more questions? Does intuition of questions start coming easily as you solve many questions? Yes, of course. Like once you start solving more and more problems, you get familiar with more and more concepts. You understand that, okay, dynamic programming, it can be used it this way. Oh, okay, we also have 2D dynamic programming, and we have bottom down and top, like whatever, like the recursive way and the other way, bottom up, something like that. So top down and all those things. You kind of understand the different patterns for different problems, and your mind basically structures that really well. So if you do this consistently, the intuition starts coming. You have solved 120 medium problems, but some questions, yeah, because 120 problems, it depends. Like if the distribution of those 120 problems is just 4 or 5 topics, then you have really done a good job in those 4 or 5 topics, and I'm pretty much sure that you have a good intuition on problems based on that. But again, like the list of topics is pretty huge, so the idea is also to do smart work, that if you pick a topic, if you are comfortable with it, there is no more point in solving more problems in that. You should move on to different problems, different topics, and try that. Someone is asking, why am I not consistent as before? 2021 has been really good year for me. I also had a lot of different family issues also, like some health issues for my parents and something like that. So I was not really able to concentrate a lot on this thing, but yeah, I'm resuming back, so things should be better now. Coding problem book, I'm not sure. I think coding problem book doesn't make sense. You do have something like uh, cracking the coding interview. I'm not really a big fan. I feel that practice, like doing coding yourself, is the best thing. Of course, reading a book and then doing this is also a good thing. But yeah, I've not read that book, so I can't comment on that. What is a programmer who does not? I think this is turning into a Q&A session. The live stream is for solving problems, so I think let's move on with a new problem that we have. Where is the problem? Yeah, submatrix one. So let's do this one, okay? And after that, we can do the Q&A session. So guys, just pick up your laptops and let's solve this problem now. If you want the link, let me paste it to the Discord again. All right. Let's do this problem. Where is it? Not this one. Okay, how do I do something like this? Let me use the pen and paper to figure out some way to do this, man. So I'm having some matrix. I'm writing upside down, I believe. Okay, so I have a matrix. And now let's talk about a submatrix. So submatrix can be from here to here, from here to here, and this will meet. So this is the submatrix, and we want to know if the sum is 0. Sum of this part is 0 or not, and we need all such. Okay. So this is like column 1, column 2. This is row 1. This is row 2. And now we want the sum should be 0, and we have to count. Okay. All right. So let's think of it in this fashion. How many submatrices exist, first of all? So you need, like, if there are n rows and n columns, or yeah, let's say there are n rows and n columns. It's a square matrix, for example. So the number of rows out of n rows, if you pick any 2 rows, then you're fixing R1 and R2. So NC2. So if rows are fixed, then the columns again NC2, right? So this is n square, n square. So around n4 matrices exist. So I just did a calculation for how many submatrices exist. So if order n4 is there, I think for every submatrix, we can figure out the sum using pre-processing in order one time. So we just iterate on the n4 matrices and just count how who all of them are having some 0. So one solution that I'm having is order n4. So let's see if that is acceptable or not, which I'm pretty much sure it won't be. But let's try to see our luck. If it had been an interview, I would have come up with this approach. The interviewer would have said, oh yeah, that is good, but we need something better. Or if not, if this is the case, they would have said, bravo, just do the implementation. Where are the constraints? Oh, this should work, I believe. So 70 times 70 raised to 4 is not that big. So I think we can pass it. So 70 raised to 4. Oh, it's big. It's big. Yeah, it's big, man. I mean, this approach will just work like this is close to like 10 to the power 8. So 10 to the power 8 in 1 second is like just on the brim. It may or may not pass. Okay. Should we try it or do we think of something better? What do you want? Like, do you want me to think something better or how is... So we can do this chit-chatting session a bit later, guys. If you have something about this session, then please ask me in the chat section. So anyone having any ideas about this problem? It's a good problem, I believe. Watching from Pakistan, I am ICPC participant. Your videos help a lot. Thanks, Abdullah. Thanks. Forgetting is a part of learning in DSA. It's a part of life. Like obviously you can't remember everything that goes inside this small, like obviously it's a part of your life. So you'll have to repeat and learn things. And obviously like your life will change once, like every 1 or 2 years, your life will change. And when you start your career as a software developer, maybe you got as a backend developer like I did, and now I'm a full stack developer and I'm very much heavily focused on front end. So life has changed quite a lot for me. Not a lot of front end developers are into competitive programming, if you understand. So things will change quite a lot, and I haven't spent the last 2 or 3 years doing problem solving or solving data structure or complex algorithms. I've been much more into JavaScript, understanding how React works. So things will change quite a lot. So someone is saying do this approach and then think about the optimization. Man, I'm a bit lazy. I don't want to do everything, but that makes sense. If it gets passed, then it's good, right? Okay, let's do this approach real fast. Let's do speed solving, okay? Okay. Edge cases later on. If n is 0 and all those things, everything later on. And is it a square matrix? Is it a square matrix or not? Of order n, square matrix, perfect. We have same rows, same columns. So for int I is 0, or let's do R1. R1 is less than n, R1 plus plus. So R1 is there, then R2, then C1 and C2. Okay. Hey, we don't really need pre-processing, I believe. Or do we? Pre-processing is not needed. We are iterating in 4 for loops. You're right, man. Before starting with the new row, we already know. Yeah, that should work, man. We don't. So basically, I was thinking of doing some pre-processing, like pre-processing to do something like prefix sum. So in arrays, what we have, like, let me do this. This is a bit easier to explain over here. So if you talk about arrays, right? So in arrays, if you have some, damn it, where is the pen? So if you have something like this, in array, prefix sum means the sum of first element is stored here, which is 3, let's say. The sum of first two elements is 13, it's stored here. Then the sum of next 3, next 4, next 5, blah, 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 and all. So once you compute this prefix sum, the good thing is, if in the array I want the sum of this sub array, I can compute that sum in order one time. How? Because I'll use this prefix sum array. So I get the sum of first these many entries using the prefix sum for this index. I get the prefix sum for this particular index. And I get the sum of this by subtracting this and this. I went a bit ahead. Again, what is the problem? Right? So if I subtract 1 and 2, I get the sum of this in order one time. So similarly, you can do this idea in matrices also. So you can get the sum from 0, 0 to everything up to some ij. So if you know the sum of this, you can compute a sum of some matrix in order one time. I'm not going to dignify that. You can take the previous idea that I had done on this page and use that to compute the sum in order one time. But I don't think we need it. Why? Because so basically in array 1, if let's say I have the sum of this R1, or let's say some index R1, right? So if I'm computing the sum from here, then this, then this, then this, I can simply store that in one variable. And when I have to go one step further, I know that it is the sum of last variable plus this element. So I can reuse the values instead of using this DP kind of thing. That's what I'm trying to say. All right. I think I have given you an idea of what I'm thinking. But now let's see how we are going to implement this, if this is really going to work that way or not. So if R1 and R2 is fixed, if R1 and R2 is fixed and C1 is also fixed. Okay. Yeah, that would be a bit tricky to implement for me right now. So I'm doing the very brute force way. I'm saying, okay, so R2 should start from R1 first of all, and C2 should start from C1. That's one thing that I was missing. Now I can say that if sum, get prefix sum, or get sum of the submatrix from R1, R2 to C1, C2. So if I get, actually let's pass R1, C1 and R2, C2. So the submatrix starting from R1, C1 to R2, C2, I get the sum. If that is 0, then answer plus plus and return answer. And this is order 1. So I need to do the pre-processing that is left, and this is the main algo. So overall time complexity is order n4. But I'm not sure if this is going to pass because we are slightly on the constraint. Let's see. Let's do the DP thing, okay? Let's see if this works. If anyone is having any ideas. Use recursion. I'm not a big fan of recursion here. Okay, DP, come on. Vector of int. Let's do it faster, man. DP n+1. Vector of int n+1, 0. What do I need to do? For int I is 0, I is less than n, I plus plus. Actually, let's do it from 1. Okay. What do I need to do is, let's see. For int I is 1, I is less than equal to n, I plus plus. Let me think what I can do. For int j is 1, j is less than equal to n, j plus plus. So I'm iterating on the matrix, and dp of ij is nothing but dp of so ith row, jth index. The sum for that will be the sum of these two matrices and minus that. Okay. So this element entry would be same row, column is this, plus dp of, I think, I minus 1 and the same column, and then minus dp of I minus 1, j minus 1, plus the element right now that we are at, which is matrix of I minus 1, j minus 1. So this is the pre-processing. So dpij is giving me from 0, 0 to the ith and jth point, what is the sum of that square or rectangle. Now using that, we can actually write this get sum. I'm going to write that as a lambda so that it doesn't take a lot of variables. Otherwise, I'll have to pass dp to get sum, which I don't want to. So it's going to return an int, and what is the syntax? I forgot. I have been working with JavaScript, but I think it will come back to me. It's something like this, I believe. It should work now. Int r1, int c1, int r2. So these are the diagonal points of the matrix. R1, C1 and R2, C2 is nothing but this is the first diagonal point and this is the second diagonal point. So I'm passing this. All right, man, let's do it fast. Capture everything with a lambda. That's important. We don't want to create a copy. So, okay. So how do I get the sum? Sum of a submatrix. Return dp of let's pass one base indexing first of all here. Okay, so now dp of, I think, r2 and c2, that's the biggest rectangle, everything like this. Let's actually use pen and paper to figure this out quickly. Pen, yellow. So I have taken everything like this. This part I have covered, right? This part I have covered. Now I want just this part, this sum I want. So I'll need to subtract a bunch of things. So what I can do is I can subtract this part, I can subtract this part, and then I can add this part again. Perfect. If it was not clear, watch it again. So basically I think C1 minus 1, this is the point C1 minus 1. I subtract everything like this. This is C1 minus 1. And then I think this is R1 minus 1. And I subtract this. Okay, so I've subtracted this. So this point, this area has been subtracted twice. So I add this back again. And perfect, this is working. If only you have tablets and pen and papers and interviews. I think virtual things have become really difficult. So minus, what did we subtract, man? Let's use this table, it's very handy. So we subtracted, I think, R2 C1 minus 1. So R2 C1 minus 1 was subtracted. Then I think we subtracted R1 minus 1 and C2. Okay, R1 minus 1 and C2. And you know why I used 1 based indexing? Because this, if you use 0 based indexing, this, if C1 is 0, this becomes negative indexing and C++ goes crazy with that. So I don't want that. And then I can add back the part which was subtracted twice, which is this word. So I think this should be good. Now let's click on run code and face the list of compilation errors. What the hell? Did you just see this, guys? Such complicated code and it's working in the first time. I love this. Oh, thanks. Again, guys, if you are still on the live stream, make sure you click on the like button if you have not done that already. This deserves 10 likes from each of you. Just do it. And also subscribe if you want more content, more notifications for interview prep content. Wow, this is working. Let's click on submit. I think we will get time limit, but I'm not going to now optimize it further. Ah, damn it. Now, do you want me to think about some optimization? Because we are not doing anything over here which can save more time. There is no CNC out. There is no map. So I think I'll need to change the algorithm if I need to be more fast. 𝗜𝗡𝗪𝗓𝗓 is saying amazing. The dream of SD. I think audience is also pretty funny, and that really makes live streaming really amazing. Thanks everyone. Okay, so how can we how can I reduce this, man? Anyone is having any ideas? It's really appreciated. What if this had been an interview, man? What would you do? Okay, let's see what I would have done. Okay, so obviously the answer exists, and I need to think about that. First, I need to drink water. So I'll mute myself and drink water. And I am back. Okay. I think there is a lot of duplication over here that is happening. Maybe we can save some space over here. So let's try to solve this for an easier version. Okay, so let's say let me use the pen. So let's say we want to solve the problem. Why is it not writing? Okay. So let's say we want to solve this problem for an array, right? Because in array, you can use prefix sum to find out how many sub-arrays exist with some 0. Okay. So 1 minus 1, 0 and 0. So for this, if you'll talk to me, how many sub-arrays exist with prefix sub-arrays, right? No, sub-arrays, yeah. How many sub-arrays exist? Actually, you know what? Let's take this. Yeah, this is a better example. So given an array, how many sub-arrays with some 0 exist? So the answer for that in this case would be 1, 2, 3, 4, 5, and 6. 6 possibilities. Okay, 6 possibilities. And what the prefix sum for this would look like is 0, then 1, then 0, and then 0, right? So if you have prefix sums, right, which is this, right. So even if two entries are same, yeah, that is true. So let's say we modify the example that we had. Let's also add 1 after 0. So now what will happen? The prefix sum will become, after this it will become 1. And now what I am saying is, yeah, this is perfect, man. Let's add a dummy 0 value over here. So now in the prefix sum, what I can say is, you can just pick any two same values, right? So for 0, there are 4 zeros, so 4C2. And because if you pick any two zeros, that means it's a sub-array and the sum is same, yeah. And you can pick, yeah, plus 2C2. So what this will become? This will become 7. And I think the answer is 7, yeah. So this is good. So basically what I did is I created prefix array And in prefix sum array, what if any two entries are same, it means that, so this one and this one is same, right? What does this mean? It means that these three elements, they are making the sum as 0, which is true. This -1, this 0 and this one, these three elements create a sum of 0. So that's why the prefix sum is same for this and this entry. Perfect. So I create prefix sum. I see how many zeros are there. 4. So 4C2. I can pick any two zeros, and whatever whatever element or whatever subrange or subarray comes in between that, it is having zero sum. Similarly, this one and this one, there are two ones. I can pick, if there had been one more one, so out of these three I can pick any 3C2, which is 3. I could have picked any two ranges. I could have picked this and this, I could have picked this and this, or I could have picked this complete thing. So there are three ways of picking two ones, which is 3C2, and every subarray over here is also having some 0. So that is the main idea. So now the thing is, can we do this on the matrix? Okay. Right. I think what you can do is pretty straightforward here. Like, think of C1. Yeah, I think we can cut down the time complexity. So let's, very easy way, let's iterate on all C1 and C2. Let's iterate on all pairs of C1 and C2. There will be n square such pairs, right? So once C1 and C2 is fixed, what I can do is, I can treat this part, right? This part. This is an array, right? Or actually, let's do it the reverse way. That would be easier for you to understand. So let's fix R1 and R2. So I'm iterating on all R1 and R2 pairs, which are order n square. So n square such pairs. But once I have fixed, so in the current iteration, once R1 and R2 is fixed, I can simply say that, can I converge all these? So let's say R1 and R2 is having more cells over here. So for the first column, I can convert all these into sum, and I can make this as an array, right? So basically, if R1, R2, R3, something like this. So R1, the entry is having 2 here, 3 here, 5 here, and so on. R2 is here, for example. And let's say here is 7, 8, 1, 2, 3, 0, -2, -3, and -5. So can I say, I can convert this into an array? Why? Because I can compact all these columns into one single value, which is the sum. So this becomes 7 to 9, this cancels, so this becomes 9. This will become 8 plus 3 is 11, and this will becomes 1. So now I got an array, right? So the idea is to look at this particular section of the matrix as an array and perform the previous algorithm on this section. And R1 and R2 is fixed, and you have n square such pairs, so you can do that in this way. And now you can count for R1 and R2, you can basically count how many C1, C2 pairs exist, so that the submatrix sum is becoming 0. So the idea, if it's still not clear, let me do it the last time. In this matrix, I am fixing R1 and R2. Right now I am focusing on all the matrices which fall in this category, right? So R1 and R2 is fixed. And if I'm iterating on all pairs of R1 and R2, and I'm, for every iteration, I'm finding how many C1, C2, valid C2, C1, C2 exist, how many such C1, C2 column exist. This will essentially give me all the matrices which are present in this particular section of the array of the matrix, right? And since R1 and R2, I'm iterating on all possible iterations, every iteration will give me a new submatrix, and I'm simply accumulating the sum of that. So if I have to explain so I was rushing right now. I was not very clear in my English in explaining things, I believe. So I think I will give it one last attempt. All right. So I'm fixing R1 and R2, and I want to know how many matrices, submatrices exist in this particular range. In this particular range, how many submatrices exist such that the sum of it is 0. So basically I am finding how many C1, C2 pairs exist. The number of C1, C2 pairs will essentially be the number of matrices in this area with sum as 0. So I want to find such valid C1 and C2 pairs. To do that, I compress all these rows, right? So this will become into single entry. This becomes single entry. This becomes single entry. So if you keep doing this for all the columns, you have an array. And you perform the previous algorithm to find out the number of sub arrays in this particular this. The sub array is essentially giving us C1 and C2 pairs. And if you expand this back, the C1, C2 with this R1, R2 range will essentially become a submatrix. I hope this is very beautiful and very clear now. Someone is saying, do these live streams daily. I am not sure about daily, but I am trying to do as many as possible, at least once a week or twice a week. But let's see. All right, thanks guys. Do you want me to do the implementation, or is that an homework for you guys? Just let me know if you want me to do the implementation. I would love if this is a homework for you. But I'm having an intuition that that's not the case. So let me do it pretty quickly. I think we are over 1 hour 20 minutes, man. Let's do it quickly. Okay. So I'm going to delete everything. Let's do it fast. Okay. Okay, R1 and R2 is there. I want to compress everything. Okay. So n square pairs. I want to compress, create an array and perform that particular algorithm that we had. Okay. So how do I do that? For R2, R1, R2, I want to get an array. So get compressed array from R1 to R2. I'm not worrying about all the details. Let's say auto arr is this, and then I can say answer plus equal to sub count sub arrays with 0 sum for this array, and then return answer. Yeah. So basically I just need to do this. How much time will this take? So this is n square. I think even if I do this in order n time, right? If I do this in order n time, then the overall thing is order n cube, which is obviously pretty good. So I need compressed array in order n time. How can I do that? Damn it. I need the pre-processing over here. I think so. I need the pre-processing. Let's see. Auto. Let's do it fast. Really fast, guys. Why is my mouse not working? Yeah, it's working. This is a lambda of obviously. It's capturing everything. R1, R2 is int. It's going to return a vector of int. And let's do the implementation over here. Okay. Vector int answer is empty. Let's not use let's use compressed array. So compressed array. So compressed array. And now we can simply iterate on I is less than n, I plus plus. And now for every entry, for every column, I need yeah, it's kind of a submatrix sum. So I could use the pre-processing. I will bring that back. I can use the pre-processing to do this really fast. Okay. Where was I? Let's use one based. Or let's, if I am using one base, then I also need to pass one base like this over here. Now, the thing is, I can say compressed array dot push underscore back. What was that? Get sum, I think. And I think now R1 comma, so the column stays same. R1 comma I and then R2 comma I. This should work. And then return compressed array. So the previous implementation was actually useful over here. So this is done. Boom. One part done. This part remaining. Let's do this. Auto. I think this can be moved out separately. We don't need it here. Int count subarray. This is a vector of int array. Let's build the prefix thing. Vector int prefix sum is essentially 0, and then for int x in array, I can say that int sum is 0, sum plus equal x, prefix sum dot push underscore back sum. So prefix sum is ready. Actually, I don't need prefix sum. I just need the count, right? So I need map int comma int count, or frequency basically, or one and the same thing. I can say count of 0 is 1, and then over here I can say count of sum plus plus. Right, I don't need prefix sum actually. And now I can iterate on for auto it in cur. I think the answer is 0. Answer plus equals it dot second nc2 basically. So nc2 value of this. I think this should work. Return answer. What is nc2? Well, int nc2 is int n. Return n star n minus 1 by 2. So this is what the implementation is. And I think we have covered everything at this point. So let me go out of, let's try the run code and face the compilation errors in this case. Oh yeah, I have not brought this get sum, right? I'll need to go to my submissions. Let me copy this in case I lose this. Perfect. Okay, so I have pasted it here. Let's go to the submissions. Time limit. How do I click on it, man? View. Yeah, this is the pre-processing part that I need. Perfect. Thanks. I think now we are good. Cur was not declared. Where is cur? Sorry, this should be count. And it seems it's working. So the test cases are working. Let's click on submit. Map was not declared. It worked here, man. What is the issue? Do I do a hash include myself? I guess so. It should work. The test cases were working. Now if I click on submit, and it seems to work. Oh, that's perfect. Now we got 100 score. Everything is working. Lambda function. Lambda function, I'm using it just because it's making my life easier. Otherwise, you can move everything outside, but you'll then DP. So if you'll notice, DP is nowhere over here, right? So if you can move this outside, but you will have to pass the DP, and you can pass by reference, but it makes my code ugly, and I don't like that. So that's why I use lambda functions. What and means that I am capturing everything by reference and not copy. So if I make changes to DP over here, it will actually reflect to the DP that we have over here. If I remove this and I make changes to DP over here, so if it's being copied by a value, so this DP, it won't get affected. I'm not really sure. Most of the times I have used reference, so I'll need to check on that once. I think it will complain if I try to do something like this. You'll need to specify that DP is being captured. If you do it like this, then it can work. But now I'll be creating copy, so it will take a lot of time. So if I now click on submit, I think it should take a lot of time, because it's capturing. so the DP size is 70 into 70, maybe because of that. But if you notice, this is 1500 milliseconds. Last one was 1300 or something. So yeah, that's one thing. So it's better if you use and. This will not create copies every time. Please avoid auto encode. Why? I am not sure why. What is the issue? I think now the compilers are also pretty smart, as well as the IDEs are also pretty smart. So if you're like, this is lead code. If I hover on this, it sees that, okay, so this is the lambda it's returning vector of int. So this auto is resolved to vector of int. So if you hover on this, the IDs will actually reflect that. So I think you should use auto. Yeah, that is true. I found one bug in the repeating subsequence that I'll notify the team. And not just team, I think a lot of websites were having that issue. I think it's a very tough problem. And probably in my next live stream, I'll come up with some, I will do some research and give you an update on that. And yeah, the other is like the test case were passing fine. But for submitting the solutions, I needed to include this. So yeah, I'll be notifying the team about this. Hello, for Q&A session, please suggest learning platform implementation of React JS and Redux. I think you don't know JS is a pretty good book. That's really good for JavaScript. And then for React, I think I learned it from a lot of YouTube videos and professional courses also, because I was having subscription from my organization. So I was able to do my learning from there. For free courses, I think YouTube is a good way for you. Yeah, so verified coder is saying thanks for the session. Wish you will be doing this at least twice a week. Well, that's let's see, if I'm able to do, I'll be happy. Otherwise, once a week should be good enough. Can you post the link to the subsequence problem? I think I did on the Discord. So yeah, it's there on the Discord. And where is Discord? I think it's pinned in the chat. So if you click on this, you can join the Discord and bam, you can see the problems. For all the live streams, it happens this way. For every live stream in the announcements channel, you have this YouTube link and the problems we solved. So that should be good. Rachit is 45 years old and this is some user AstroD. Well, okay, yeah, I will be in almost 20 years from now. So yeah. I'm 26 right now, by the way. So 19 years. It's a long time. Will I be doing YouTube by then? I'm not sure. Alright guys, I think this session was really fun. Thanks for joining. If you have still not liked the stream, please do it. I'm not sure why you're not doing it. And make sure to subscribe. And we have a bunch of live streams in which you can actually do this kind of sessions on your own pace. So I think this was the 16th live stream, and you can check the description if you want to go through the other one. Like, we have a bunch of live streams, so you can just open and fire your laptop and then, just start solving problems. So I really love these live streams. First of all, like, I think it's a very good way for you also to practice. And obviously it's a very good practice for me also to brush up my DS algo skills. But I'm really happy that I'm still able to solve problems. And even if I'm stuck, the thought process is still not lost. And I think that's the thing. Like, even if you're out of touch, if you're a good programmer, the approach or your thinking capability, that will not go. So the only thing is probably you can make more bugs, you'll miss some corner cases, but the way you think, that will always improve with time. When you're a programmer, you'll always start writing more clean code. And that's what's happening with me. Like, just because I was working in an organization where C++ is heavily used, I was able to understand a lot of C++ advanced features. And this is like really basic stuff, like using auto and then lambdas. These are like really basic things. In fact, like, when you'll start doing a lot of things, when you're working as a software developer, you will learn a lot of things. And this is crazy, like how much you will learn. Even in C++, I think I started this repo of modern CPP tricks. So this is like so much awesome stuff that can make your C++ code neater and faster in the terms of writing your and faster in terms of writing code. So your speed increases because there are so much of fancy things which are coming, and I was not never aware of that. So you can have a look at this. Like if you want a minimum of multiple elements, you can simply do something like this. No need of like doing this nesting min. Then we have destructuring also. So if you have a pair, you can do destructuring like JavaScript over here. So yeah, I mean, like I work extensively on JavaScript and C++, and I'm really happy how C++ is also shaping and evolving. But yeah, I mean, JavaScript is something that has really, captured my attention, and I'm exploring that a lot. All right. I think this stream was amazing. Thanks everyone for joining, and I'll see you in the next one. So thanks for joining, guys. Bye bye.